So if anybody's been following the net, and I know everybody has, this young lady over here, this is Stefany Allaire.
Yes.
Stefany Allaire, and she is from Canada, and where the money is worth a lot less than ours, currently. Who knows about next week? She is the developer, the brainchild, behind the C256 Foenix. And this is a brand new, from the ground up, retro style computer. When you see all this information and look at this board, as soon as you pick up the board and look at it, you look like it was something that was made in 1985. It is an amazing job on it. It's beautiful. She says it's sexy. So she came all the way from Canada to give us a presentation. So Stefany, would you want to be there? I can flip the camera around, or do you want to have a peer, or how are you doing this? Okay, all right. So Stefany Allaire.
Hello, everyone. How are you? Good. Are you ready?
Yeah.
It's going to be a long run. So hold on, I'm going to remove my. I'm going to be hot really soon. Okay. You excited? New stuff? New weekend wasted programming? You know, well, not wasted. All right. Is it too loud? Is it too not loud enough?
Perfect.
All right. Camera person?
Yes.
I'm moving a lot.
That's okay, I'll follow you.
You sure?
I'm going to stalk you.
You're going to stalk me?
Yep.
Okay. I'm sorry I'm going to sound like Arnold Schwarzenegger because I've been talking all weekends. So, no, don't do that. And, so first thing first, yeah, my name is Stefany, and thank you for coming. I'm French-Canadian, so my first language is French. So, je parle français. So I would like to apologize at the beginning because I tend to repeat myself a lot and use the same words because my vocabulary when I start talking to people goes from 20,000 words to about 20. So please forgive me for this. So, like so, you know. So let's get rocking. All right, so the agenda today, which is very thorough, so I'm going to talk about myself. I'll try to not spend too much time on this. Where this project is coming from, how it happened. So what is a C56? And the specs. I think we're going to spend a little bit of time on specs. Maybe we'll take a few questions, or maybe we're going to wait at the end, I don't know. Then I'm going to give a status of where we're standing. I mean, yeah, I could say we. And finally, where we're going, what do we need, what's going to happen, and my wish and dreams for this unit. And I guess we'll take questions from that. Unless there's questions along the way, maybe it's better that way. We'll see. We'll improvise, I guess. So, who am I? Yeah. Okay, so like I said, I'm French. Yeah, it's not my fault, sorry. So, I was born in Quebec City. I too, like a lot of people in this community, has started, you know, they were like, you know, 14, 13, whatever. Commodore came out, the father bought a computer. Actually, my father bought it mostly from my brother, but we paid like $1,000 for it. It was like really, really early on, and we waited like 2-3 months or maybe more to get it. And then finally we did, but for a while we didn't do much because there was not a lot of games at that time that were available. So it took a year, I think, before we actually started doing things when my brother started to go to college and they had this computer club. And then the cartridge started coming in, and then we had a cassette, the tape drive, right? And we started playing with it. Like the first game was Forbidden Forest. So I'm sure everybody knows Forbidden Forest. Like the sound was awesome. The game was like great. Anyway, so moving on. For me, at that time, I was the one who got the most interest in it, and I started tinkering into it and started doing like everybody was doing, which is, you know, opening up the big manual and start digging into it and trying to do something. We came to the conclusion that writing stuff in BASIC was pretty slow, so we kind of forgot that. And then later on, I got myself into the hacking. So I started hacking games, and because my brother was bringing games, and okay, Stefany, do you want to hack them? So I was doing hacking jobs and stuff like that. So I was going through on my screen, I didn't have a lot of contrast, but here I had a lot of contrast. Here you don't have a lot. Sorry about that. Anyway, so my handle was the Navigator. So if you have games that says cracked by Navigators, that was me. And then later on, I started a career in electronic hardware, electronic design, and I've been doing that for 20 years. I started in many companies. I failed miserably at it. At some point in 2008, I started doing FPGA design, mechanical design, because when I was in one of those companies, I was kind of my own, so I kind of had to do everything. So I became pretty good at designing products overall, because I had like a bigger vision of what should be done and how artistically speaking, I was like, versed into seeing or having vision about how it should be, although it doesn't mean that that's the way it should be, but anyway. Aside of that, I've done a lot of design, electronic, I've done software stuff, I've done a lot of stuff. At some point, I went to Hollywood. I stayed there for 5 years, trying to get in the movie industry, failed miserably again. And you have to understand that every time I say I fail, it also means that I've learned some things. I've learned a lot about myself. So I also learned that doing any vanity project for myself was really not a good idea. So you have to understand that this is not a vanity project at all. Otherwise, I wouldn't be here, I guess. So I came back from LA in 2013, and I wondered a while. I didn't know exactly what I wanted to do, and I kind of quit a little bit the hardware design thing because I was fed up. It didn't work, and then I started writing, screenwriting, and novel writing, and I'm not that great at that either. Although I think my stories are great, but the writing sucks. But ultimately, I don't know what happened this year. I've been on YouTube. I've been watching YouTube stuff for a while now, and I was watching the A Bit Guy. So most people know David Murray's channel. And in April of this year, he started talking about. He's making the review of this really cool. That's the what's the name? It's written on it. The Gigafron, which is a CPU made out of TTL logic. And it was like he's making the review of that product and everything, and at the end, and throughout times he's been reviewing many homemade computer like this, but every time he was like always coming with a comment saying, it's not exactly what I want. So during that episode, at the end he says, I've decided to make a list of the things I'd like to have, like my dream computer. So I go on his website, go see the list, and I was like, oh, this sounds like an 8-bit Amiga to me. Like that struck me, and so I wrote on his forum or blog. I said, challenge accepted. I didn't write anything else. I just said, if you go back, you'll see my post and say challenge accepted, and I went on with it. So I thought about it for a while, and I just how I could come up with it. And so basically, I'm trying to deliver to David his dream computer. Okay. At the end of the day, he created this list, and I had my own vision of it. So he laid it out, and I'm playing it out the way I think. But that was only one part of the story, because what happened next was totally, I didn't know what was going to happen with that. I thought I would only be doing that on my basement, just doing my stuff, and just one day coming up with something in 2-3 years, maybe. But in the time I was actually starting doing the schematic capture, I decided to use Eagle because I thought, okay, this is going to be an open source project, so I might as well start using a software that people can have access to. And even if I was new to it, I kind of learned it pretty quickly. But I didn't feel like creating all the schematic, the symbols and everything, so I started using a website like SnapPDAs to download my schematic parts and my footprints. And basically what happened is that one day I was doing my stuff, I got an email from the CEO of SnapPDA. She's great, her name is Natasha, and she sent me an email and said, hey, you're my 100,000th, person who's been registered to the website. Cool. So, and she comes and said, well, do you want to do an interview? I first she thought that all the components I was downloading was for a work project. I said, no, I'm working on this project. I started talking to her about it, and she was super excited. I said, yeah, okay, cool. So she came up with a bunch of questions. Actually, we did like an audio, like Skype type interview. She wrote a blog about it, and she posted on LinkedIn, and then from that moment, everything else just happened. So you see, I didn't have to do anything. It just came by itself. So after that, excitement built, and people start, coming to the website, asking questions. And I started the website in the meantime, getting some specs, and we'll be talking about these specs eventually, but they've been changing a little bit. But even at that point, I had like a vision. And my vision was really, what would have happened if, for example, Jax never went to Atari or got kicked out by his own board, and that Commodore never bought Amiga. And I think, and I feel that the fact that I never had an Amiga, I never touched one at all, ever, was like, okay, maybe this is my version of the Amiga that maybe Commodore would have built. And in order to make it more exciting for me, I was like, okay, I need to make it so it's going to be interesting and fun to use, but also in terms of designing, I need to set some rules, because otherwise I can do like the Amiga 65, just coming up with like an FPGA and put it on the PCB, and then I'm done. I can do everything on an FPGA, and it's going to be easy peasy, right? So I set myself on the path to say, okay, it needs to be like if it was designed in 1987, which was about the year the Amiga 500 was released, right? So that was my rule. So I need to do that this way, and then I went on to think, okay, what do I need? What do I want in terms of graphics? What do I want? How far do I need to go? But I need to set some rules. Otherwise, I will again be designing something that will be over-designed, will be too much, and it's not going to be interesting. So the Amiga was a good example. So I did my research, I went around, and I had my idea. So I said, okay, for example, the VGA needs to be a certain way, the graphics needs to have certain things, more sprites, always a little bit more what the C64, C258 had, but not too much. And again, Amiga was always my baseline. This is what we had at that time, but it's still an 8-bit computer. Although I'm using an 816, which was one of the requirements of David's. And that was always on the back of my mind. David's list is my go-to things, but you can tell that David's is not very much into FPGAs. He would have probably to have like off-the-shelf chips, but to have like features like sprites and glitters and stuff like that, you're not going to find anything like that on the shelf anymore. So I had to come up and say, I'm going to use FPGAs, but I'm not going to use a big one, I'm going to use a very small one, and they're going to be DQFPs instead of BGAs. Nothing that makes us think that it's like a design like right now. And so that was one of many rules I set for myself, and decided that, this is how this project should be. It's going to be fun for me because it's a challenge in itself. I mean, you have to look for these components and find them. I mean, even one of the Super I/O, the chip that takes care of the floppies and everything, was like, you need to find it. So this, like the SIDs, like you need to find them. I know people love their SIDs. I found some, although I'm not even sure they work, but I did find some in China. But some people told me, sometimes they sell you like chips that were rejected in production, so maybe they work, maybe they don't work. But we'll talk about this later. So, where am I now? So, this is what the C256 is, and it's a vision of what possibly could have happened if things would have turned out differently. So that's my rules, and I try to stick to that rule and to have the same look, the same feel. And that was also one of my priorities, is to make it as Commodore-esque as possible. So when you're going to get one, if you get one and you power it on, you should feel that, okay, this is it. This is what I think it should be. Since I have like a thing against like emulation and Raspberry Pi, sorry. For me, I'm kind of a purist in that sense, that for me, I need the real thing. Anything else is just like, Anyway, so this is the vision, and I think I covered up pretty much make it, yeah. So one of the things is that I wanted to make it accessible and make it flexible. I wanted to make it, you know, basically designing a toy for people to use, to program on it, to make it, you know, as much as any other computer we would buy these days, like small stuff like microcontroller boards or anything like that, easy to use. One of the things that was very important for me also was to bring something that could be easily programmable by bringing more tools, programming tools for developers, and so it would not be it would not need a big overhead to get into it. Document it as much as possible, and to make it open source, except the FPGAs. The reason for that is that, in my mind, the FPGAs are ASICs that Commodore would have designed, and obviously Commodore would have not given you the recipes of their chip if they would have designed those chips. So for me, the FPGAs are off limits, but everything else is open source. The kernel will be open source, everything will be. Otherwise, yeah, the time period, and I have to, trust me, it's difficult, okay? It's finding things in dips and stuff like that. It's more difficult than I thought. Yeah, that's what I'm saying. Okay, so we're going to address the elephant in the room, okay, about the C64 compatibility, because this is something I got a lot from the moment I got the interview. A lot of people came onto site, checked the specification. Oh, is it going to be compatible with the C64 and blah, blah, blah. So here's the rule. The rule is that I've done everything I could to make that board as compatible in terms of input-output to a Commodore 64. The cartridge is like a Commodore, the pinout is like a Commodore 64, the user port is like a Commodore 64, the IEC is there. There's even a connector to put a C64 keyboard. But I didn't set out to create a C256 with C64 compatibility, okay? But it doesn't stop somebody in the field to say, I'm going to use that unit with the FPGA and all the resources because the SIDs are there, so this is something you don't even have to emulate, and use this hardware with the schematics and everything and create a C64 with it. And maybe ultimately merging the two together. But for my, when I set out to do that, for me the C256 needed to be its own thing. Okay, so this is, we're starting from scratch, we're creating new software, and creating new games, porting new games, whatever. We'll put everything we can to make things easy, but I didn't want to make it a C64 because there's so many ways to get a C64 these days, it's just redundant. So that was a point of contention because, you know, there are still people, oh, I would like to have this, but I would like to have still being able to play my C64. I'm not saying it's not possible, I'm just saying that I'm not going to be the one to do it. I'm sure a lot of enthusiastic people out there will do it, and really quickly, I'm sure. And they're probably working on it right now, so you never know. I'm sure as soon as the schematics are out and they know what kind of FPGA I have, trust me, it'll be out. Yeah. So this is the least of my worries. I'm sure by the time it's out for people to get, it'll be done. Anyway, there's a lot of VHDL code for simulating a VIC, I'm sure, so it should be pretty easy, because I think, bottom line, that's pretty much what you have to do. So everything else is pretty much there. Okay, so you don't see very much there. No, I'm sorry about that. Oh, no. Okay, the specs. Ta-da-da! All right, so the specs. In David's requirements, his CPU of choice was the 65816, and for me, it was perfect. Okay, and I will be honest with you, there was some ideas at some point in the process to put actually two processors. Some people came to me and said, hey, you know, it's the following brother or sister from the C128, why don't you do like a dual processor thing? And for a while I was thinking about putting a 68HCS, the static version, which has an 8-bit mode to it, and make a dual processor version. And possibly, eventually, maybe you could do it. Maybe a C256E. And yeah, so that could be fun. But after a while, I just like, you know what, one processor will be just enough already, so, and we'll create a lot of problems. So I said, you know what, I'll put it aside. But maybe for future release, maybe a two-processor version. So the specs are at 14 megahertz. I know we can overclock this processor. I decided not to. That was a choice. I know people will try to make it faster, although it's 3.3 volts, so 3.3 volts at 14 is already close to the maximum. It would have been 5 volts, it would have been a little bit faster, but I decided to stick to 14. Also because it's a multiples of the burst color frequency, which is used across the system, so I kind of, to keep everything synchronized, I thought it was the best way to do it. So 14 it is. Okay, the memory. We're going to have 8 megs of memory, ladies and gentlemen. So I think you'll have enough. I hope you will. Although the chip I'm using, and I will explain the story of this very quickly, you can actually have a 16 meg version as well. But, you know, the story is that early on the system was going to have like 1.5 meg of static RAM inside the system. 1 meg dedicated for the video and 512K RAM, thank you very much, for the code. Which was early on again the requirements of David's requirements about how the memory size should be. And then obviously I got people coming on the forum and say, yeah, it's not enough, it's not enough, it's not enough. I said, well, okay. So I started thinking, okay, I'll put 4 megs. But you know, I don't know if you know, but 4 megs of static RAM these days is $50. Doesn't seem like much, but you know, it's still a lot of money. Would you pay $50 more or $35 more just to get 4 megs? So I started looking around and say, okay, what about dynamic RAM? The dynamic problem is these days is that if you use dynamic RAM, they're dead cheap, but you have you start with 120 meg chip. So yeah, that's a bit too much for me, right? But I came about this great part. It was perfect, it was beautiful, it was like so synchronistic in nature, because Cypress Semiconductor came out with these parts, which are really tiny, and they have like 20, it's a VGA. Okay, this is one of the anachronisms of my board. There's a small VGA, this is the memory, it's DDR memory, it's 10-pin interface. So the controller is already integrated in the parts, it's 8 meg, and it costs $2.50. So, I don't know, I think it's a great choice, you know, they didn't have any 4 megs, so, and they have a model with 16 megs. So I said, you know, 16 would be kind of stretching it, so 8 megs will be sufficient. So, $2.50, good deal, and it's a DDR controller, so it means that I'm running 100 megahertz, so I'm going to get 200 megabyte per second of throughput. So that means a lot of music, a lot of graphics, it's going to be fun, right? So that was my pick. I said, and it's very low pin count, so it kept me from using a VGA for FPGA because I was kind of running out of pinage. So I decided to stick with that. I said, okay, people will complain or maybe not, or they'll be happy, but this is the choice I make. So, yeah, maybe. Do you want me to change the text so you can see it? Or it's okay? Oh, I can run through it. All right, well, you'll have to get up again. Okay, so basically for the FPGAs, yeah, in terms of, before we get into the FPGAs, the flash and the EEPROM, I put 2 sockets on the board. One for the kernel, which is 512K, and you'll have inside the basic interpreter whenever it's going to come out, and the kernel. And there will probably be a monitor like the C128, and there'll probably be have a text editor included as well. And this will be a flash, so which means that the idea is that we could actually reflash the kernel in time, considering that, let's say we want to release the unit without having BASIC, because that could be something that could delay the whole release of that platform. And so there'll probably be a way to actually upgrade the kernel to have new features in it if we find bugs and stuff like that. But I put another one for anybody to put. This is a customer-oriented flash or EEPROM that you can actually either choose one or the other and implement like your own version of something or whatever. So this is really to one of the aspects of the flexibility. So open it for people to put whatever they want in it, and being a ROM that you run in your system, or you sell a ROM for the system for people to use in their system. So, and it's 512K as well. So unless we do a big GUI system environment where we go outside the 512K, I think we're going to have enough, so plenty of space to write code. So, now the FPGAs. So everybody still wake up? Yeah? You're doing good? Yeah? Awesome? Yeah, he's gone. It's okay. Well, I saw him. He's gone. I'm not interested. Of course. I'm the master of all villainy, I'm gone, you know. Anyway, moving on. So, 3 FPGAs on the board. They have 3 names. As per the proceedings, that's how we should do it, right? So 3 names. The first one is Gavin. The Gavin is the system controller, that's the one at the bottom. Gavin is mainly responsible to deal with the CPU and to prefetch the information for the CPU. Basically, Gavin is there to satisfy Mr. CPU and just give him what they want to proceed and to work and to do all that stuff. But to make sure that the bus on the other side is free and available to do a lot of transfer, because there will be a lot of transfer to be done. Also, there will be, Gavin takes care of the interrupts controller, and also Gavin is also, there's a debugger on the development platform, because the first version I designed was a development platform that developers will have. The user version might not have this feature, but it's basically a USB 2 serial, which is the second anachronism on this board, and it's connected to Gavin, and it's the tools I gave myself to be able to use or to take control of the system through to a PC. So when you interface to USB, you'll be able to connect to it and take control and debug your code. So if any piece of software that exists that, what's the name of Arthur's software?
CBM Program Studio.
Okay, CBM Program Studio. So this software you could use the software to create stuff, to create games or whatever, and then connect the USB and download your code directly and just run it and see if it works and debug it and see what's going on really on the machine. So it's really like in the machine debugging system. So Gavin takes care of that because it tells the CPU, oh, okay, shut up, I need to do some stuff in the system, download the code, read code, and tap or read the memory, write the memory, flash the flash, or stuff like that. So this is really Gavin's role, and I don't think it will do much more than that. The second chip will go from the bottom up. The second one is Beatrix. Her name comes from Beat Matrix. She's responsible for the sound. She doesn't create sound, she's a sequencer. Because on the board we have a lot of sound. I mean, a lot of sound. Okay, so it's going to be awesome. So there's, as you probably know, everybody saw on the board, there's 2 SID chip, so it's a stereo system. And there's 2 OPL2 chip that was used on the Sound Blaster. So basically, you have 2 SID chips, 2 Commodore 64 sound chips, 2 Sound Blaster chip. So which gives you 12 channels of sound per year. So that's going to be a lot of sound. Thank you. Thank you very much. So this feature, the Beatrix takes care of the fact that SID chips interface is 1 megahertz, and the OPL2 interface is 3.8 megahertz. So they're 3.58 megahertz. Very different. One is dealt differently than the others. So our job is really to take the DMA information from the memory controller and just feed the data. And the beauty of it is that all those chips will be able to be written at the same time. So they are individually addressable. And every time you ask the sequencer to write to them, they'll be written at the same time. So which means that you'll create the notes at the same time, as opposed to start feeding all the details sequentially and having enough set into the writing sequence of all those chips, which sure at some point would create a problem. So that's her job. That's it. That's all she does. She just takes the data, just writes at the right time, at the right moment to the right chip, individually. And then finally, we have the one we don't see, and maybe it's better that way. I'll tell you instead of you freaking out. So this is Vicky. Vicky, ta-da-da! So Vicky, so she's the big boss. She's the big boss. And she's taking care of a lot of stuff. First, she's taking care of the memory controller. So she's the one dealing with the access of writing and reading from the memory chip we talked about before. She's also connected to the LPC. So the LPC, the Super I/O chip. The Super I/O chip is a Super I/O chip that used to be used in the PC world. So it takes care of the floppy 2 serial ports, parallel ports that are all compatible with PCs. So anybody who wrote anything for the PCs in the past will be able to use that as the same thing, same code, same thing. This is where the MIDI controller comes from, so it's MPU 401 MIDI controller, it's in there. Same thing, same register level, easy enough. And the keyboard interface, PS2 keyboard interface, mouse, same thing. This chip uses an interface called LPC, which is a reduced low pin count PCI type connectivity system. It's 4-pin, it's nibble driven. So it's 33 megahertz, but you have to send everything in nibbles, and there's like this protocol you have to follow to. So I've been working on this weekend. It's almost working, although there's a A20 line problems, but we'll come back to it anyway, eventually. So she's taking care of that. The idea to put it there was really the fact that when you actually burst stuff from the floppy, it would go right directly in the main memory. So you don't have to wait for the CPU. The CPU doesn't have to do anything. You say, hey, read this file, put it there, and it's going to do it automatically for you. Time saved. And this is one of the reason for me, I mean, I knew 14 megahertz was great, but it was not super fast. But the idea was really to get the CPU to do as less as possible. Okay? I want this CPU, when it's running a game or something, to grab ass and just do nothing. Just let everything go and everything, and just taking care of the logic. Well, obviously it's not going to grab as much, but anyway, you get the gist. So then we get into graphic modes. So Vicky is a graphic controller, 2D engine. You'll have the original resolution will be, the overall resolution will be 800 by 600, which is the maximum. Out of this, you'll get a text mode, 80 column text mode, which will be 640 by 480 with the borders, like the Amiga 65 does. Actually, that was his suggestion. I thought, no, this is a good idea. Why not? Although you could actually do bitmap in 800 and 600 or 640 by 480. The C256 will be supporting multiple font set, the PETSCI, although it's going to be a redone PETSCI version for copyright reason, I'm sure you understand. Maybe a slightly different PETSCI, but still. The ASCII, the IBM ASCII, and probably another one. There will be a 8-bit mode and a 16-bit mode height. We'll be supporting that, plus all the characters, plus the keyboard, because we're using like a normal keyboard, then we'll support all the characters for all these keyboards. So there will be attributes for all these text thing. There will be a monochrome mode. There will be a monochrome but with color, like 16 colors. Only those 16 colors you'll be able to choose from a palette of 24-bit palette. So this is really the concept behind this computer. Everything is pretty much, aside of the font, that will be like nibbles to choose the colors in the background. Everything else, you can actually have a font model. I mean, it's not going to be embedded in the system, but if you want to have font with 1 byte per pixel, you'll be able to do it, to use it and do it, because that's basically what games would be using. And always referencing to a lookup table. There will be a lot of those lookup table. So that saves us a lot of time, a lot of bandwidth, and since we don't use like a ton of colors anyway, I mean, we would want to, unless you do like really fine shading, you really don't need that much color. So it's going to be perfect, and that's the way things will go. After the fonts, you'll have the bitmap, standard bitmap stuff, and you'll have the sprites, the beautiful sprites we all love. So right now, the sprite thing is, and all these things I'm talking about right now are all still in the air, because things could change, could get better, could get worse. I mean, it depends on the logic I have. I try to stick to something not too big, not too fancy, because it would, just make no sense at all. But I still want to make things better. So one of the things to make things better is to just increase the number of sprites. So it would be 32 sprites, that's the number for now. The sizes of those sprites would be 32 by 32, although I'm thinking about making them like scalable. You can change the size, so it could be 8 by 16 or 23 by 43, whatever. It could, not 43, but 24, whatever. So the idea is to make it more flexible. So if you want to create a character with sprites, then you might not want to have all these big sprites, or you just need like, if you want to create a bullet, a ball or something, you don't have to use a 32 by 32, you just use a smaller one. That kind of stuff. Sorry. So these are the sum of the features. You'll have blitter, DMA transfer, all these things, maybe a display list of sprites for a lot of beautiful stuff. I'm sure people love it. So in a nutshell, this is what Vicky's job is. So she's the core of the system, and she's the one also taking care of DMA and all the audio data to feeding the data to Gavin for the CPU and feeding the information for Vicky. No, for Beatrix. Yeah. So that's it. So this is for the and finally the I/O, and I've talked about it a little bit. So Super I/O chip takes care of the internal floppy 1.44 3.5 inch, and always forget 3.25. No, 3.5.
Yeah.
Thank you very much. I always mix both.
Yeah.
Okay. So aside of that, my beautiful and gorgeous Jim here will be taking over. Now the deal is, like I said, the Iec Connector is there in one end to support the 1541 and 1571, 1581, and it was important, and so we'll be supporting the format of the old format, and the internal drive, however, will be supporting both, which is CBM DOS.
CBM DOS, right?
Is that the way you call it? And the FAT32 system, so you can literally read stuff from the PC and get your stuff in there through the PC. So he's the programmer. He elected himself and said, "Hey, yes, I want to do it." Is that what you said? No, that's not what you said. Like, you've been allocated for the next 3 months to do programming. Listen, he's the top guy when it comes to floppy, so I guess this is the guy. I put your name down for my milestone schedule there, so
Okay.
awesome. So you better tell your wife that you won't be talking to her for a while.
Oh, she's used to that.
Okay.
It makes her happy.
So in terms of IOs, in terms of the system, we have, let me go through them individually. So we have the PS2. I know that's going to annoy a lot of people, but I'm sorry. We'll see eventually what we can do to fix that. But for now, PS2 keyboard, PS2 mouse, 2 joystick port. However, the analog portion, they're individuals. They're not connected to the SID. They're connected to the Super I/O because the Super I/O had the same kind of analog conversion. So the reason to do that was to isolate myself from the fact that probably we'll change the SID to something else eventually, because I don't want to take all the SIDs that remains with this, because the barbarians will get a gate and just kill me. So this is not happening. The SID, like the purists, SID purists, you know, I wouldn't want the European to show up at my door. Okay, so keep going. So we have the cartridge port, which is the format is a PCI Express connector, which is a by 4, 64 pins. The first section, the larger section, holds all the signalings of the C64. It's 5 volts, same thing. The only thing you would need is an adapter, and I'm sure somebody will rise to build it. Yeah, go figure. I'm looking at it right now. Yeah. And then the other side is 3.3 volts, and this is the expansion, the section, which is the extra addresses that you would need to go further than 64K, and a few extra signals, some audio input or output, I don't remember, and yeah, cool stuff. You know, everything else aside of one thing on the Commodore side is exactly the same, and the one thing is the dot clock, I think. Yeah, there was like a dot clock running there. I don't know if people uses it. Anyway, so that I couldn't replicate because I would have created a clock just for it. And eventually, this board doesn't support that. Eventually, I will probably have a pin on the extended part to actually switch the 5 volts to 3.3, the 5 volts Commodore section into C64 section into 3.3 volts. So you can have both voltages. So anybody creating a cartridge for the C256 won't have to put translator on their board. So it's would be completely easy, 3.3 volts. All right, moving on. So we have the Iec connector here for the floppy. You all know this. Video-wise, yes, I debated with myself a long time about, okay, do I go really retro on this one? Do I just put in a VGA, like an old Brooktree RAM DAC in there? I'm still debating, but it was 5 volts. I would have had to have more translators, and now that's gonna, just kill the whole thing. People will kill me again. So I said, okay, I went on with this video DAC, which that supports both. So I have analog output, which is VGA output, and DVI, which is HDMI. So you should be all happy now. So all satisfied. So there's nothing else I can do aside of that. You know, HDMI with audio is not going to happen, so forget about it. So, MIDI in, MIDI out. I'm sure a lot of people will like this one too. And the RCA output is the audio out for the purists to put like on the real amplification system, which can be awesome, and a lot of bass and a lot of sound, like a freaking orchestra in there. The user board. And you have to realize that everything is mini here. It's like mini everything, because the enclosure idea, I didn't want to go into molding. It was just, well, at first I didn't want to go into molding, so 3D printed was the way to go. And my bed size is just only so big. So, and that's also the reason that drove me to not have a keyboard part of the project, because keyboards are expensive, and I would have needed like a big printer. So, and also it's small enough that most people with a 3D printer could probably print it. So that's the reason. So the user port is smaller. It's the same pin out, aside one pin that is coming from the 6526 that is not available in the 6522. So it's not there, so I don't know if I put anything there or nothing. And the 9 volt is not there. Sorry about that, guys, I wish. So the pitch for the connector is smaller, but everything else is there. Finally, inside. Ooh. Okay, inside. Okay, thank you. So this I will call Jim's connector. Okay, this is Jim's connector. This is an IEC. These are the signals. It's like what was the name of the other board? The black board, you know, the CN4 connector.
I don't remember.
You know the Commodore board that somebody redesigned with the ZIF connector?
Oh yeah, that's a reloaded board, you mean?
The reloaded board.
Yeah.
What's the connector name?
CN4B.
CN4B, yeah. That's a CN4B
Yeah.
plus more.
Yeah.
So this connector is to allow my friend here to actually redesign one of his this thing that you
The micro drive, yeah.
The micro drive to fit in there so people can use SD card. Yay! But you realize how paradoxical this is, right? You want like an old thing, but you want a new thing on it. This is, yay! Come on, guys. So I made a point to not put an SD card on the board because, you know, it's an old thing. But yet, I had to cave, to this guy. So, put a connector inside, Well, I did, okay? So, everybody's happy and satisfied. It's so great. Anyway, so inside, there's an expansion, a full expansion full expansion connectors. For anybody interested to build expansion cards, you know, sound capture thing, Wi-Fi, anything that your heart so desire that is 2018-ish, you know. We could actually put like an IDE interface to put a hard drive, like a SATA drive maybe, something crazy like this. Yeah, you would go for this. And an i7, right? Yes, an i7. He wants to put an i7 inside. Yeah, sure. Or a Raspberry Pi maybe.
No.
Okay, if anybody put a Raspberry Pi on that thing, seriously, I'm going to go show at your door and I'm going to do something really bad. Okay, no Raspberry Pi on that board, ever. Okay? Please. I ask you, please, no Raspberry Pi. Okay? And don't get me wrong, the Raspberry Pi is cool and everything, but no Raspberry Pi in there. Seriously? There's a ZX something in the UK, they're doing exactly that. They put a Raspberry Pi with a big FPGA, I'm still wondering why. But anyway. So this is all the signals of the system, although the signaling are after Gavin, in between Gavin, so we have access to all the signalings and everything, so anything, you feel like you can put on, and then you can actually connect, customize this bracket with 3D printing and just put the connector you want to the board, and there's a way to attach it. So that should be one way to actually expand it and to make it more yours and more personal touch on it. Otherwise, there's the parallel port. You know, back then with the PCs, you remember we used to put those brackets with those 9-pin, 10-pin cables and 26-pin cables to the back. Well, these are compatible with these pinage. So the reason I did that is actually to find a way to free the bracket outside so we could actually replace them, because I'm sure not that many people will use them, although I don't know. Jim already prepared himself a way to put like a modem in there. One is Wi-Fi modem, so yeah, it should be useful. Although it's going to be inside, so it's going to be fine. Otherwise, this connector here is for the floppy. The floppy is in the cover. I'm sorry, I'm going to move myself here next to my 20th Starbucks. So this is the floppy, 3D floppy in there. Normally there's a cable, okay, attaching the two. It's not Wi-Fi or anything. There's an RTC in there. You probably noticed it because of the big battery. So big battery, big leakage in the future if you forget it in the storage. So
that makes it retro.
Yeah, of course. So a super RTC, a real-time clock with real-time and everything like 6526. You know there was a real-time clock in the 6526, right? Took me a while to realize that. I go, oh, look, there's an RTC in the 65. I didn't realize. Okay, so that's that with the IOs here are, and here's the sound, the two SIDs, the two Yamaha chips, the two DACs that comes along, some audio amplification, mixing, and then here you have the headphone with the small amplifier to really make your game experience as great as possible. To enjoy those sounds, those beautiful sounds. Alright, so let's move on. Are you tired? You sure? Wake up calls? You want to take a break? 2 minutes? No? You're good? Nobody's sleeping? He's eating. He's browsing. No browsing, dude. No browsing. Stay focused here. Stay focused. All right, let's move on. This plug is that this is beautiful, isn't it? I don't want to spend too much time in there because I covered pretty much all of this. So this is really the structure. It's very out of focus here. But it just covers every section of what I've talked about. The CPU, Gavin, what they do. Although that was an earlier version, because the Super I/O, which is on the left side, your left, yes, went to the right side, and memory controller stayed there. And yeah, the interrupt controller that was on this side went on this side. So that's the only changes that happened to the block diagram. And yeah. Any question for this at this point? Or you want to keep the question for later? We'll come back to it. All right.